All right, these are some classic optimization problems, some quick work ones. So we'll do both, 2 and 3. These are from Stewart, section 4.7. Find two numbers whose difference is 100 and whose product is a minimum. All right, you don't know the numbers. I always call them x and y. So on problem 2, I know that x minus y is 100, right? Difference is 100. And I want the product, which I call p, to be a minimum. What's the product of? It's of x and y. Does it say the numbers have to be positive? It does not say the numbers have to be positive. I would expect these numbers to be negative to make the product, one of them to be negative, one to be positive, is what I would think. All right. I want to optimize the product. This formula. Well, the problem with that formula is it has two unknowns. So I'm going to solve for x up here and say x is equal to 100 plus y. And I'll put that in my product. Product min. And I get 100 plus y times y. Do you guys agree the formula becomes product min is 100y plus y squared? Now everybody, we do our little happy dance. Yay. Alright, because we now have one variable and we can optimize by taking the derivative, p min prime. I think it's 100 plus 2y. And everybody, we can set p min prime to 0. And I think I get, and guys, you plug 0 here, right? I think it's negative 50, right? Y is negative 50. Okay? And I can go back now, and I can find x in this equation, which is just 50. So find two numbers, all right, whose sum is 100, whose product is a minimum. The minimum is negative 2,500. It didn't ask you to find that. It asked you to find the two numbers. The two numbers are negative 50 and positive 50. And it comes back to our very first thought when we started the problem. Our very first thought was, yeah, one of these is going to be a positive number. One is going to be a negative. 50 minus a minus 50 is 100. Product of those two is a minimum. All right. That was 2. Let's do it in red. 3. Find two positive numbers whose product is 100 and whose sum is a minimum. So two positive numbers whose product, x times y, is 100. Where x is greater than 0 and y is greater than 0. You guys agree? And whose sum, and I'm going to write SUM, is a minimum. Sum of min, and that means x plus y is a minimum. Guys, I hate the S's notation. You guys know my S's looks like 5, so I'm going to call this m equals x plus y, because we want to get a minimum. So I'm going to call the equation m equals x plus y. My problem is I have two variables, and I can only have one. I'm going to solve for y up here, and say y is equivalent to 100 divided by x. I'll plug that in. And if I bring the x to the top, you guys agree it's x negative 1? All right. Now I do my happy dance. Yay. And I take the derivative, m prime, which is the sum, to be a minimum. Is that. And then I said m prime equal to 0. And looky, this time I'm going to write out the equation a little bit here because this one tends to get students just on the algebra side. We're done with the calculus. We really are. Now it's just solving it correctly. I'll do that in black. So 0 equals 1 minus 100 over x squared when we bring it down. So 100 over x squared equals 1. 100 equals x squared, multiply both sides. Now everybody, when you solve for x, you should get plus or minus 10, right? Square root of both sides. But that's where this initial condition becomes so important. So I use x is 10 because that's our positive solution. Find two positive numbers. If x is 10, obviously y is 10. That comes back to this rule right there. They're both positive. All right. So find two numbers whose product is 100 and whose sum is a minimum. All right, two positive numbers. The minimum sum is 20. If you were allowed any numbers, it'd have to be negative. You guys agree? Then it'd be negative 10 plus negative 10 is negative 20. And then you have to check them, right? But that's why the language is here. Again, solving simple word problems with optimization.